So thank you for the invitation, Stelios, for this very nice meeting for the cost action for Harmonia. I will try to give some information on the vertical distributions that have been already discussed by people here, such as Melanie, Stefan, and Marilisa, to bring some new instruments that recent missions that are actually flagship European missions related to vertical profiling. One of them, a very successful one, is Aeolous, and the second one that we schedule for the future at the ESA level is EarthCare. Both are Earth Explorers, so they are actually new instruments that are being tested. This is why we have so short lifetimes, such as 3 to 5 years. It's not an operational mission, but we are preparing for that in the future. For example, we have Aeolous 2 from EUMETSAT being planned from 2030. So this would be a future for Aeolous, while we know that NASA, after Calypso, we will also launch second LiDAR in the Atmosphere Observing System, which is a constellation of new satellites expected to come again in 2030s. So Aeolous is well known, and you most probably know about this system for the wind product. So this is a wind mission, a flagship Doppler LiDAR system that has been put first one in space ever. This is a thing that European industry managed to achieve. And we have products that have been shown by ECMWF from the respective assimilation of the wind profiling product that we had an improvement of NWP, right? Especially when it comes in the free troposphere. So we have better weather forecasts through Aeolous. What is less known is that Aeolous have a second product. It was called in the beginning byproduct. So it was just an aerosol retrieval that has been not taken much attention. However, we tried to correct this product to evaluate and see if we can use it, because this was the first aerosol chance to get aerosol information from space, from a European LiDAR, right?
Yeah.
Somebody is...
Πώς θα τα βλέπαμε.
Ναι.
Πώς θα το βλέπαμε. Να σου πω τι έκανε η Μαριλίζα.
Γιατί ακούγεται η φωνή σου από εκεί μέσα?
Ακούγεται καθόλου.
Μπορείτε λίγο να κλείσετε τα μικρόφωνα. Νομίζω τα κλείσαμε. Νομίζω τα κλείσαμε. Έχετε κάτι άλλο να κάνετε?
Θα το...
Θα κάνουμε μετά. Okay. So, sorry for the interruption. This was the last slide, okay? So before using this product, we should evaluate it, to validate it, to follow the procedure for how to do that. We had a campaign.
Λοιπόν, κοίτα τι μας έκανε η...
Συγγνώμη, με ακούτε λίγο οι αυτοί που παρακολουθούν από μακριά? Ακούγεστε, μπορείτε να κλείσετε παρακαλώ τα μικρόφωνα. Ευχαριστώ. So this is the Cabo Verde Islands where we installed some instruments in order to evaluate and improve, optimize the Aeolous aerosol product, okay? What we do, national facility related to aerosol and cloud remote sensing, because the product of Aeolous contains both aerosol and clouds, it cannot separate.
Το link είναι αυτό. Έτσι δεν είναι? Και λες αυτό είναι. Αν δεν είναι αυτό, το link θέλει, δεν το τσίπεις ολόκληρο.
Και αποδομήσεις αυτό εσύ, Δημήτρης.
Και τα βάλε μέσα.
Ναι.
Όπως εγώ το έχω πει στο περίμενο.
Δεν ξέρω πώς το κάνω. Νομίζω σταμάτησε.
Α, πάει, το κάνει ο Γιώργος. Το κάνει ο Γιώργος. Έλα, κάτω Γιώργο εσύ, Πάνε share.
This is Marilisa's presentation.
Γιώργο, μπορείς να αλλάξεις την παρουσίαση, γύρισε με στις Μαριλίζας. Ναι.
Thank you, Giorgo. So this is, sorry for the interruptions. This is actually the instrumentation that we installed in Capo Verde, okay? So we have ground-based lidars, photometers, cloud radars, everything in place in order to provide quality assured datasets for validation purposes, but also for optimization of the Aeolous provided products. On top of the instrumentation that we had from Actris, we have also developed at NOAA, along with a Greek company, Raymetrics. You see here Peristera and Nikos from NOAA that developed this system called EVE. This is actually a small Aeolous that we developed in order to operate from ground and actually deploy some channels that were not available at Actris level. So these channels were related to circular polarization. So Aeolous has this unique feature that does not emit linear depolarization, linear polarized light as Calypso, but it emits a circularly polarized light and detects the polarized returns. Why this is significant? Because, as Marilisa said before, for Calypso, in order to distinguish between aerosol types, you need to have some features that are related to their physical shape, for example. And depolarization is one of them. If you have non-spherical particles in the atmosphere, then the depolarization gets some significant values. So you can discriminate between dust, volcanic ash, and other particles, okay? And this is how Calypso does it, actually. For Aeolous, we try to validate these features and what it finally detects. And in order to do that, we are combining the measurements also with in situ measurements. Because we were evaluating profiles, we developed over the site airborne measurements for in situ, but also remote sensing. And you see here the aircrafts operated at that time. We had DLR, we had CNES, but Latmos, but at the same time we had people from NASA with the DC-8 aircraft, and also Grisa, who is here as well today from Slovenia with light aircrafts capable of providing in situ measurements within the dust layers. We use that with co-located ground measurements to evaluate the retrievals. So this is a first comparison on what we found out with EVE, how well Aeolous performs, what is the accuracy of the product. Actually, for aerosols, it goes relatively well. However, you see here in this plot provided by Antonis that we have some problems here when we have dust cases, okay? So the concentration is severely underestimated when we have dust, so non-spherical layer. Why is that? Because we realize that Aeolous does not detect the cross channel for the polarized returns. So it detects only the parallel component. And what that means that when you have dust, or in regions affected by non-spherical particles, you get underestimated products for aerosol, but also for cirrus clouds, for example, because ice crystals depolarize the light as well. And you see here an estimation. We used both channels from Calypso, with Calypso to estimate what Aeolous underestimates in reality. And this is what is the level of underestimation, can go up to 40% for the dust belt, right? And now we have a new ESA project when we are trying to correct that product for the missing cross channel. And we do several methodologies. I will not go into details on that. But what we do is to try to use synergistic information. We use a product provided by KNMI, a test product for cloud screening. We use, in addition, geostationary information for clouds to remove them from Aeolous overpasses. And then we use some information from CAMs in terms of aerosol types. When we get dust, then we're trying to correct the product. So after doing that, we aim to run some experiments in order to exploit the product, the aerosol product of Aeolous, and demonstrate what would be the impact in several applications through data simulation mainly. So here is an example that we ran with Barcelona Supercomputing Center by assimilating the dust product from Calypso, okay? So I'm coming back to the discussion with Melanie, what you can do when you have typing from space. Calypso can separate dust, so you provide dust concentration directly from the observations. So the model won't have to assume that in the total aerosol load, a certain percentage is coming from dust sources or the other from other sources, okay? By doing so, you have the following results that provided by Ensa and Carlos here in a related project we have together for ESA. And this is related to the Godzilla episode, the well-known episode with huge amounts of dust transported over the Atlantic. You see here what you get from the free run without observations. And here by assimilating the Livas profiles. So you have the Caribbean here affecting, the Godzilla affecting Caribbean in large, huge concentrations, which is the reality. Actually, this has been measured there, okay? But you don't get that when you don't have assimilation through the profiling. And why profiling is important? One reason has been already mentioned by Melanie, but she also mentioned the following, that if you get the layer in higher altitudes, then you have different wind fields, usually higher winds in higher altitudes, and then you get a significant long-range transport, okay? So this is why it is important to get profiling from space and typing from space, okay? So we ran for Aeolous also an assimilation example here with ECMWF, with IFS. We had a coupled meteorological model. So we have here a first improvement of the aerosol field when we assimilate Aeolous-like profiles, aerosol profiles. But also you see here, this is a work by Antonis in the framework of Adkros, Adonis Gikas, and you see here how also the vertical profile of the winds is affected. So we have a feedback, we have actually a better numerical weather prediction for the wind fields. It alters the wind product because it affects heating rates, atmospheric thermodynamics, and then you get a different wind product, which improves, especially when it comes in free tropospheric layers, again here, where you have the presence of the Saharan dust episodes. And this is visible also in 2D, where you have the outflow region here. These are the differences, control, and assimilated runs. So you have an impact on CAMs for atmospheric composition, but also an NWP impact, which is the main objective of Aeolous. This is why we launched Aeolous, to improve our NWP capability. And so the synergy of wind and Aeolous and aerosol profiles can do this difference, though it hasn't been tested. And what we tested so far was only the wind assimilation, and for case studies, some aerosol assimilation. And what we aim to do in the framework of the L2A Plus project, we are developing with Thanasis, who is here, a nice assimilation system over WRF using DART. And then we want to assimilate both products to see the double impact, let's say, of Aeolous in the assimilation process. And our aim is to see, because here you see how much Aeolous affected. This is the second or third mission in terms of impact in NWP through assimilation after IASI, but IASI actually assimilates 2 or 3 products at the same time. So we want to do the same for Aeolous to see what we get from a combined assimilation experiment. And furthermore, by improving and optimizing this product, we want to fill gaps we have in the climatology that we built. It's called Livas. We start from Calypso. We aim to go through EOS of NASA. In between, we have missions such as Aeolous, Aeolous 2, and EarthCare, of course. So we are trying first to convince ESA and EUMETSAT for Aeolous 2 to implement the cross-channel in order to get a better product, aerosol and cloud, and for Aeolous to correct what we have already at hand in order to integrate in this database, in order to develop, to build a climate data record for trends, for climatological studies. And the second plan we have is to upgrade with Peristera Eve system in order to make it healthcare compatible and organize a large-scale campaign in the Mediterranean where we will deploy Eve. We will apply all the actress access framework, so you are invited to apply for an access to be funded actually to join us in this campaign. And we will follow some CalVal protocols that we develop right now for CEOs, for space profilers. This is a large community effort from NASA, ESA, and JAXA. We have the joy and we are very glad that we coordinate this activity in order to come up with the best practices for LiDARs, cloud radars, and precipitation retrievals from space. And this is the plan we have, along with Greece at the moment, with Cyprus Institute, NOAA, and other partners from INOE, Romania, from Italy, CNR, in order to build an exploratory platform with full instrumentation of remote sensors at ground and some airborne facilities. And we also want to invite, and these are some discussions pending right now, open to come also ESA could join, in order, NASA could join actually, sorry, with ER2 aircraft in order to provide high spectral resolution LiDAR measurements over the Mediterranean. This is the last slide. I just wanted to invite you in this campaign. I know you have very nice photometers to participate, so please join. Thank you very much.
Thank you very much, Vassili.
Join the action, join the newsletter. Follow us on social media for news and announcement.